Dr. Romano. Looks like you're up to physics again.
Hi, I'd like to go over a question with you that's going to be a challenging problem to illustrate the second law of Newton. It's going to have 3 parts. Let's have a look. What we're going to do is we have a block of 4 kilograms. It's being pulled by a 50 Newton force at an angle of 30 degrees to the horizontal. And the coefficient of friction is 0.60. And I'm going to ask you 3 things. Find the normal force, find the force of friction, and find the acceleration of the system. The first thing to approach questions like this is to draw a free body diagram. When I draw a free body diagram, I'm going to draw a pictorial depiction of the object and show all the forces on it. Well, what do we got? We got the weight of the object, which is mg going down. There's the force that's due to the surface, that's the normal force, that goes up. The block is being pulled at 50 newtons at 30 degrees. So there's the picture. And then notice I make a little x-axis out of it, xy axis, as you can see. So this force is going to have both a horizontal and a vertical component because it's on an angle. Since the object is moving to the right by this force, the force of friction always opposes motion. So it's to the left. All right, where do we start? Well, the normal force is in the y direction, so that's where we're going to start. Now, I'm going to take this away for a second, just to show you how you would approach it. The first thing to do any problems on Newton's law is to write the second law of Newton, which says F equals ma. What I do here is I modify it a little bit to say the sum of the forces in the y direction equals ma(y). The normal force is in the y direction, so I start there. Look with your eyes. What do you see? You got the normal force going up, minus mg going down, and then you got 50 sine 30 for this force component. Why sine? Because the angle is opposite. As you can see, the y little axis. So let me say it again. The reason why you're using sine is because this force component is opposite the angle. Here's where most kids really get wrecked on an exam. The acceleration is going this way. It's going horizontal. There is no vertical acceleration in the y direction. So therefore, you put in a 0. That's the trick. So we're going to get the normal force minus mg and 50 sine theta. The sine of 30 degrees is a half. You get 25. You bring the mg to the other side, plug in mg, and the rest is pretty straightforward. You get the normal force is 14.2 newtons. Part B, this is a gift. What's the force of friction? Well, the force of friction by definition is the normal force times mu. The normal force is 14.2. Mu is 0.60 from the original. That gives me 18.52 newtons. Part C, what is the acceleration? Well, obviously, it's being dragged along the horizontal in the x direction. So I write F equals ma, but I use my little component technique. The force in the x direction and the acceleration in the x direction, the sum of those forces. Going back to the free body diagram, what do we see? Minus the force of friction plus 50 cosine of 30. Why cosine? Because the horizontal is along the x-axis. And the mass was 4 kilograms, and there's my unknown. We already know the force of friction from part B. You plug it in. You evaluate 50 cosine 30. They'll give you what the cosine of 30 is on the exam. And as you can see, you solve for the acceleration being 8.7 meters per second squared. Although this was a longer problem, there was many parts to it. So the trick was not simply plugging into F equals ma, but to be able to analyze it using what's called a free body diagram. Remember, in physics, the free body diagram is our best friend. All right, hope you enjoyed it. I'll see you again. If you got any questions on this, hit me up in study group and see the Physics Destroyer.
Thanks, Dr. Romano. That was great. I just wanted to tell you my friend Joe got into Harvard. Do you
Very
think
good,
I
Joe.
will?
Very good. You? No. Good day to you.
Good day to you, sir. I'm trying really hard. Good day to you, Dr. Romano.